Before I start the session, I would like to announce something. There's a purse, a lady from, of course, a female purse left in prayer room. So if anybody has lost it or something, you can find it in the prayer room. Okay? Thank you. Actually, it's a very important session, a very informative session, this one. As you all know that we have started the space program in the United Arab Emirates. And we have a lot of long cooperation and collaboration with NASA, especially Hamad bin Rashid Space Center. So I would like to welcome Engineer George Sotomayor, Lead Increment Scientist, International Space Station Program at NASA Johnson Space Center. We'd like also to welcome Engineer Noor Abu Raid, Research Assistant at Hamad bin Rashid Space Center. It's a research center. I would like maybe just go into history a little bit, and then I'll start the questions. We all know that technology really started, I'm talking about remote technology, started when telephone was invented by Alexander Graham Bell in 1876, sorry. So that was a wired communication. And then in 1900, Marconi changed it into wireless communications. And later on, in 1928, it was pulsated, the signals, which is the famous sampling theorem by Nyquist. And then we go into 1948, the three famous theorems of Claude Shannon started the digital era. And at the same time, the digital transistor was invented. Then we went into the space. In 1957, the first satellite was launched. And then later on, in 1961, there were passive satellites, and then it came into active satellites, and then there was the communication satellite, ComSat. Mm-hmm. In 1969, of course, it was a big event for the whole world that NASA actually landed the probe on the moon. So that was the beginning of big challenges. And from there, the whole communication started to make more sense. Technology made more sense. And the same year also, internet was born, 1969. And it continued growing once the internet was there, the wireless communications was there, the digital communication was there. It was time for us to visit the space more than often. And many probes were launched to go to to Mars, to Moon, and even to other planets. UAE had a vision. And one of the elements of the national strategy for innovation have seven sectors. One of them is space. It was transportation, it was health, education, water resources, it was renewable energy, space, and technology. These are the 7 ones. So space became something very important for the country to explore and become one of the 9 countries who have have taken the journey of going to space. So here we are today. We are going to discuss first to understand more about NASA, plus also to understand about Hamad bin Rashid Space Center. I know they started earlier at the EXPO, Emirates Institute for Advanced Science and Technology, then it turned into MBRSC. And this was the beginning for the country. We already launched, I'll keep it to maybe to Noor to talk more about it, but we launched a probe, and we went to the International Space Station, and so on, all together. Of course, this collaboration was very important between UAE and other countries of the world. One of them was United States, NASA. So I welcome you two both on this interesting topic for this kind of discussion. Now, since this is called a Technology and Space Applications on Solving Environmental Challenges. So now we are specifically looking at the environment. What is the role of space or space shuttles or satellites regarding how to improve the environment and create a green economy or a green environment? So maybe I would like to start to ask about NASA. How did you start, and what were your achievements, and how did you start working with UAE?
Mm-hmm.
Please.
Yes, yeah, thank you so much for the invitation and for the introduction. I'm very thankful and honored to be here today. Yeah, it's a pleasure. And in terms of NASA collaboration with the UAE, it's been coming along for quite a few years, very years in the making. And as a matter of fact, and I didn't bring that picture, but I had the pleasure of meeting Haza and Sultan when they were in the Johnson Space Center training. Yeah, and that was right before Haza launch to the space station. So we've been working on different with UAE in different areas. One of the areas of a lot of interest is the human body. Yeah, what happens to the human body, human physiology, when it's exposed to microgravity and the environment of space in general, radiation, and all of that aspect of it. So that's one that we're continuously working very actively with the UAE. Then the field of robotics and actually getting ready for habitats and eventually getting ready for not just the moon, but continue on to Mars. So we continue working that with the UAE. And very recently, not only we have the two previous UAE astronaut candidates, but now we have two new ones. You have two new ones that they just started training in last month, January. So and including the first woman from the UAE astronaut. So and for them, it's going to take about 2 years to be ready. It takes some time for them to get ready for flight. So we're also looking forward to that as well. So we have several UAE astronauts lined up. Mm-hmm. Yes.
You have a presentation to present right
Mm-hmm.
now? Can you
Yes.
do that, please?
Yes, sure. And okay.
Yeah, you can
stand up over there? Or?
Yeah. You can walk, whatever.
Okay, so I can read. So NASA, in terms of the climate change, we have several initiatives going on. And what I'm going to talk to you first is NASA as an agency, what we're doing to address the problem of climate change and natural disasters. The first one shown here, the National Climate Task Force. And this was a task force created by exists by the President Biden and the President Biden's administration. And he requested NASA to be part of this task force in order to address and find solutions to problems related to climate change. So this is really a very important milestone. As simple as it sounds, it's very important to actually get the country and the agency involved, NASA as an agency involved in climate change. As part of that, the NASA administrator, and the NASA administrator reports directly to the President of the United States, the NASA administrator created a position of a climate advisor. And as a matter of fact, it's the position of the chief scientist, but now the chief scientist also has the role of the climate advisor. and this is Dr. Catherine Calvin. So we're really looking forward to having her at the helm as the chief scientist, but even more so as a climate advisor to the administrator. Then we have, and these are all upcoming missions. A new mission coming up is the Earth System Observatory. And as a matter of fact, this is a set of 5 satellites that are going to be launched, and they're going to work all together in tandem to monitor several aspects of the Earth. The objective is that they will help mitigate and guide efforts on climate change, disaster mitigation, fighting forest fires, and improve agricultural processes. So we have 5 satellites, and they're going to address these conditions. One of the satellites is going to focus on aerosols, particles in the atmosphere. Another one, cloud convention and precipitation. And this is looking at precipitation, the formation of clouds, rain, and then storms, and how that impacts the climate. Mass change, that's another one where we're looking at how the topology, the geography continues to change, and also an agricultural, from an agricultural basis. Surface biology, geology, looking at the surface itself, how the crops are being impacted by different climate change. And surface deformation and change, that last one, and actually that's the last one on the list, but that's the first one that's going to launch in about a year, in January of 2023. And that one is in collaboration with India, with this Indian Space Agency. And that one is going to measure surface changes, for example, glaciers as they melt, the ice caps as they collapse, earthquakes and how they affect the mass of the Earth and the shape of the Earth, how the surface changes and deforms. So that's the first satellite to be launched, and we're really looking forward to that one as the beginning of this effort. This Earth System Observatory, it's really a $2.5 billion effort in collaboration with other agencies, and it's going to take about 10 years to actually launch all of these satellites that will then, once they're all on orbit, they're going to create a 3D map of the Earth and looking how it affects all the way from underground all the way to the atmosphere. So it's going to be really, really interesting, and it's a major effort that we're going into. Also, we're going to launch. Actually, this Landsat 9 just launched last September, and it's going to track impacts of global change, and it will help farmers and scientists manage land resources that contribute to human life, and this relates to food, water, forests. Landsat 9 is going to be work again together with Landsat 8, which is its sister. So, and the two of them, when they're working, they will actually take a look and measure the entire Earth every 8 days. In collaboration, the Landsat 8 and 9 satellites, in collaboration with ESA, the European Space Agency satellites, they will actually be able to look at any given point on Earth every 2 days. So they can actually, it's going to be an active tracking of changes on the surface, as a result of global change. INCAS, this is, it studies tropical storms, thunderstorms, and the impacts on the climate model. The objective is that it will mitigate weather and climate effects in our communities. And again, when we're talking about thunderstorms, we think about when we've had this, the storms are becoming stronger over the years. And actually, over a very short period of time, they keep getting stronger. So we want this satellite to be part of this analysis. Expected to launch in 2027. And then tropics, which it gathers the storms, precipitation data, temperature, humidity, but it's looking specifically at the tropical belt where most of all of the hurricanes and cyclones form. So we want to look at that in more detail. This one in particular is a set of 6 satellites. In 2021, last year in June, a Pathfinder satellite was launched, but again, it was just to ensure that the communication path, that everything was working properly. But of the next satellites, the 6 next satellites are planned this year. So now I'm going to talk to you, and again, this is NASA new upcoming initiatives. In addition to all of these, we already have over 24 satellites on space, on orbit right now, as we speak, including satellites, observatories mounted on the space station. So, and one thing that at NASA, what we want to make sure is that this data is not exclusive to NASA, but it's open to other countries as well, so that other countries can look at it, analyze it, and see how this climate change will impact their countries. So again, this data is available to others. So now what you're going to see, speaking about the space station, is a video, a very short video, showing how the space station was built. It took a lot longer than 2 minutes, but so you can see, and then have a glimpse of the items, or what we're looking at as part of the space station. I like that video a lot.
Yeah,
So,
beautiful.
yeah. So, like I said, the space station took a little bit longer than that, to get built. And it's again a collaboration of many countries, several space agencies, including the European Space Agency, Canadian Space Agency, the Japanese Space Agency, and Roscosmos, the Russian Space Agency. So. So from the space station, we are also working different investigations to look at Earth. One of them is the CEO, or Crew Earth Observations. And this one is a very simple investigation where the crew members actually have their hands on a camera and they take pictures down to Earth. But usually for Crew Earth Observations, we ask the crew to take specific pictures of specific areas. For example, whenever we have volcanoes, for instance, erupting. So we ask the crew members to take pictures of the volcanoes, landslides, flooding, forest fires. So these are all activities that we ask the crew members to take pictures of while they're on orbit. So again, this is one of them, but this is handheld cameras. We have another one that's called EXPO-SCIENCES, and at NASA, the scientists are really creative because EXPO-SCIENCES stands for Ecosystem Spaceborne Thermal Radiometer Experiment on Space Station. So you see all those capital letters? That's how EXPO-SCIENCES came about. So what do you think? What came first, the name or the acronym? So yeah, they're very creative. So this one, EXPO-SCIENCES, studies the surface of the Earth using high-resolution thermal infrared sensing. So in reality, what it's doing is it measures how stressed the plants are. so by measuring the temperature of the plants. And actually this is the sensor, and let's see if we have the video that shows how it operates on orbit. There's no sound on this one. So it detects using infrared laser. It measures the temperature of the plants on the surface of the Earth, and based on the color, it can detect if the plants are healthy, or even if they're going into drought. But actually, it can detect a drought condition even before they get there. So this is really good because it's a preventative measure to identify and tell the farmers on the ground and the scientists that something is coming, something is happening. It could be drought, it could be a disease on the plants. So these satellites provide, this instrument on the space station provides that information to the farmers on the ground. We have JEDI, and again, they come up with these names, Star Wars kind of a thing. Global Ecosystem Dynamics Investigation. And this one uses a high-quality laser to map the forests, and actually it does that in a three-dimensional pattern. And what it does, it wants to better understand the amount of carbon stored in the vegetation. And now remember, when we talk about deforestation, forest fires, we know that they contribute to climate change, global warming. But not only because of, if it's a fire, because of the carbon dioxide that is being released because of the fire, the combustion, but also the trees, they store the carbon. So when they die, they also release that carbon into the atmosphere. So this one helps to have a better understanding of how much carbon is stored. And it's, and again, another instrument, and this portion is the GEM, which is the Japanese module. It sends laser beams to the ground to map the forests. And based on the light that bounces back, it can determine the height of the trees, how dense the trees are, and then calculate the amount of carbon in the forest. And then we have other instruments, for example, the OCO3, Oxygen Absorbing Carbon Observatory, and this one studies the dynamics of the atmospheric carbon cycle. SAGE-3, that's another one, Stratospheric Aerosol and Gas Experiment, and it studies the ozone layer as well as other gases and particles that reside there. And this one takes measurements by locking onto the sun or the moon as the station is orbiting, and then scans the limb, that profile, the thin profile of the atmosphere. Then we have TSIS, and it's a total and spectral solar irradiance sensor. And this one, what it does, it establishes the Earth's total energy input and understand how the Earth's atmosphere responds to solar changes. So what that does is that it measures how much energy is coming from the sun into the Earth, and then how much of that energy is being released back again. So it can do the math there, and then it can tell, hey, this amount of energy is still staying within the atmosphere that contributes to global warming. Mm-hmm. So, and again, that all of that energy drives the atmospheric and oceanic circulations. So this, again, this is just to give you an idea of experiments that we have ongoing right now on the space station. There's more information, a lot of information, and again, this is free and accessible to the public, and it's at climate.nasa.gov and also at science.nasa.gov. And again, the resources are there, available for everybody. So, all right, thank you.
Thank you, George. Thank you very much.
Thank you. Thanks.
Well, let's move to UAE now. UAE satellites for monitoring the environment. I think the satellites that they do, some are owned by UAE and some are not, right?
Right.
But before I say, you may need to talk about also the research center in the University of Dubai.
Sure.
Mohammed Barashi Space Center, the research center in University of Dubai. And she's working there as an employee for MBRSC, but in University of Dubai. Please go ahead.
Right. Thank you for the introduction and thank you for the wonderful talk. I'm very happy to be here today, and I would like to present MBRSC Lab as best as I can. This lab was inaugurated in June 2018, so we're still kind of young, but we did very big things. As I said, in June 2018. And ever since then, we have worked on various projects. Some of them were related to the environment and some of them were not. But even those that were not related to the environment, it did give us some indication related to that in one way or another. At first, MBRSC had only Dubai satellite, and then they had Khalifa Sat. Now they're working on Mohammed bin Zayed satellite, the next step. And with each satellite, the resolution becomes better and better. As the resolution becomes better, it enables us to do more. And last year, in March 2021, they launched DMSat satellite. It's a micro satellite, and it's the first of its type in the region. And it was made specifically to monitor the environment here in the UAE. So what it does is that it monitors the aerosols in the atmosphere. Of course, some of them are from dust, some of them are from chemicals, things that pollute the air. And as we receive information from the satellite, we will be able to visualize which areas exactly suffer from this, which areas emit these aerosols the most, and based on that, we can mitigate this pollution. Recently also, we worked on a project with Al Ain municipality. And the project was basically about automatically detecting palm trees, because farmers usually go to the field and they count palm trees manually, one by one. And it's a very daunting task. There are over, I think, 4 million palm trees in the UAE. And of course, it takes a tremendous amount of time to go through.
40 million.
40 million, sorry, yes, I was off by a large margin. All right, so 40 million. And of course, it takes a tremendous amount of time to go through each and every palm tree to assess their health and such. So we were able to develop an algorithm to count the palm trees with a certain accuracy. I think it was about 97%. And the next step of this project is to assess automatically the health of these palm trees. So with the success of the first step, we're very excited to continue working on this. We also worked on a project related to oil spill detection, again, from satellite images. So I think the most interesting thing is that you have so many sensors. Each of these sensors measures several different things. So when you combine data, when you deal with data fusion, you are able to get out even more information. And that's how we were able to detect oil spills by using SAR images. And this is something, I think this is a very huge threat to the environment at the moment, because not only it's important to detect the oil spill, but it's important to detect the thickness of the oil spill, because the thicker it is, that means you have better chances at clearing that one first. If it's not thick, that means it's already a little bit down below, and that one is harder to clear. So it's better to start with the thick ones, and so on. Other than that, we have been studying the urban sprawl in the Dubai region. As you know, Dubai region grows very rapidly. Every other day there is something different. Every other day there's a building. It's very It changes very rapidly. So how does this affect the environment, the urban sprawl of Dubai? As it progresses more, is it a negative effect? Is it a positive effect? This is also one of the things that we keep an eye on and we're interested in studying. Other than that, for the projects related to the environment, I've already mentioned DMSAT, and as you already know, also MBRSC launched the HOPE probe recently, and we're very excited to get pictures of that one, and we will go to study images beyond that to space.
Thank you, Engineer Noor. The thing is that UAE, when they started to, before I say maybe, UAE looks at any project differently. They look at it very carefully. One of the things they do in UAE is that first of all, they try to collaborate with industry and around the world to transfer the technology. But that's not enough. They try to change it later into transfer of knowledge. So at the end, we want to make sure that whatever is done is made in UAE. So when they started the Dubai Sat-1, the engineers from MILSET Space Center were sent to South Korea to get trained. So 30% of the engineers who designed the satellite Dubai Sat-1 were 30%. And that was the beginning of technology transfer. Dubai Sat-2, we had sent more. It became 70% of designers who are designing, and 30% South Koreans. And then Dubai Sat-3, which you call it Khalifa Sat, 100% were UAE nationals who designed completely the whole satellite. It was a proud moment for all of us, actually. And that's, this is where we started. And again, the Mars probe was also designed 100% by UAE nationals. So it seemed like this is what anybody wants to do. Technology transfer is not enough. You need to actually make sure that you transfer the knowledge, the how-to. You need to how-to. You do it yourself. And so the probe was there, and the DM satellite actually means Dubai Municipality Satellite. That's the one that Noor was talking about. Now in DIWA launched a satellite, and we need to also collaborate with them. Inshallah we will. So the drive towards becoming a space-based country, UAE is that one. But they can't do it alone. They collaborate with all the space agencies of the world, and has been successful. If I ask you, you of course from all these researches you do, you analyze the data and so on, you have published a lot of papers, right?
We have a lot of, yes, in reputable conferences, journals, and so on. And not only we publish, we also make something usable for any governmental entity that can make use of the deductions that we produce. That's basically one of the goals and missions of our lab, to bridge the gap between academia and the industry, and bring them both together.
The research done is nearly more than 30 papers. It was published, and all of them for the last 3 years only, 3 to 4 years. This means that, yes, we want to add our knowledge into the satellites. And this is how the research comes in. Research is applied to the industry.
Sorry, if
Yes.
I may add as well, we are also very active in the area of risk assessment. So we are also working on studying how the earthquake that happened sometime in the last year. There was not an earthquake, I think it was an after effect of the earthquake that came from Iran. So we studied what are the areas that can be that can receive the most damage if a real earthquake, God forbid, happened here. And not only our studies are restricted to the UAE, we also studied the damage that was caused by a tsunami, again, in the recent year. And another project that I forgot, I just recalled it. You know, as the effect of global warming becomes more prominent every year, you know, the sea level keeps rising. And so we're studying which areas of the UAE will be submerged and by which year, according to, you know, predictive analysis and statistics and such.
Thank you very much. Now, if you go into the future technology for real-time environmental monitoring, I mean, you talk about you don't want to do something and then after a while you get the result. We are talking about the real time. Is that possible? Do you think it will happen?
At NASA, we do have all of these satellites that provide results very close, to real time within days. In terms of acting, and that's a big question. How quick can we react to that? And that's what we're trying to learn. We're producing models, predictive models, that can tell us, based on the pattern that we're seeing over the last decade, 2 decades, 50 years, based on that data, what should we expect? For example, in terms of agriculture, the weather patterns are changing, and the soil continues to change. So maybe at a given year, the crops of corn and wheat were adequate for a specific area, but not anymore. So as we learn with all these data which direction we're heading, we can also modify and adjust. It may not be as quickly as we would like, in terms of a very quick real time, but when the people, the industry, the governments take notice of that, then they can adjust and prepare, be better prepared for that. In terms of rain, the weather patterns, you know, the areas that used to be dry or are dry are becoming more dry, and then the ones that were wet are even more wet. So, but sometimes they even change the location. So what we want to know is be able to predict it to some extent, so that we can be better prepared. Like the satellite measuring the rising level of the sea, of the ocean. So we want to be prepared for that.
That's very interesting. Actually, there was a scenario we discussed in the University of Dubai. Let's say that rises maybe a meter or something, then Dubai will be drowned completely. What is the solution? And this was to think about something. Maybe we need to close the Gulf so that you can, you know, and then cover it with taller things. So these kind of scenarios are part of that, right? It's very important to look at that. For us, when we do this data science and so on, and we analyze all this kind of data, does it take a long time? I mean, how long does it take? Do we have that computers that do the number crunching?
Depends on the size of the data you have, depends on what you are trying to do. For us, we analyze images, and satellite images are very large. We're talking about gigabytes. And always, the more data you have, the better your predictive analysis are. So we do have very powerful machines, like with very powerful GPUs and such, and it could take sometimes a week to run an algorithm and get the results back. And the worst thing is when we get the results back and there's something unexpected, then we have to repeat. So we're really, like, we lose time sometimes. So of course we try to avoid mistakes as much as we can, because the more time we save, the better. But yes, it could take a lot of time, and I think this takes us a little bit to the topic of big data. I think all the topics are interspersed. You're talking about environment, you're going to talk about data, you're going to talk about big data, and then eventually AI and such. So yes, powerful machines are important, and even with powerful machines, you still have to do some sort of data management to get things going.
Yeah. Actually, data manipulation is too complicated. It's not just simple, just to see what's happening. You have to throw some out, some in, and so on.
Right.
And then you need an artificial intelligence to make it quicker and so on. At the end, can we reach one day that we can do it in less than a second to completely analyze it and do it? I mean, that's the real time we're talking about. Do you think that's possible?
Yeah. I think, you know, what happens is that 50 years ago, 30 years ago, we had a technology, and we thought it was really good. 5 years later came different technology, and now we have more information. We're here today, and with the satellites that we currently have on orbit, we think that we have good data. But now, for example, from the NASA perspective, we're launching at least 15, 20 new satellites within the next 10 years. And then the data is going to be even more accurate.
Yeah.
Yes. So we're going to, we build predictive models based on the information that we have, on the best data that we have today, and the best computing capabilities that we have, that we can analyze it. And so that's going to be an ever-changing effort. Hopefully someday we will be able to get there. Yes, and that would be great. Now, you also mentioned something about technology transfer and having this information. And at least in my perspective, when we talk about global change, it talks about global change,
Exactly.
the whole Earth. Yes, the whole Earth. And it's a question, and the answer. But the question is, so we have countries like the UAE, United States, in Europe. Their countries are working very hard to mitigate these global change, climate change. But then, what about those countries that do not work on it, but still are causing the global change, climate change? So how can we work, different nations, and work all together around the globe so that we can actually improve the entire global weather? For example, one of the satellites in one of those websites that I showed you, you can go in and it shows the carbon emissions from the Australia fires, and you can see them over time, and they were generated in Australia, but they very quickly moved around the globe. The same thing with the California fires and anything like this. So yes, we are fighting, and we need to continue fighting that battle. But I think it has to be done at a global level so that we can mitigate all of these risks at different countries around the world.
You know, I like, there was a GEO, there was a MEO, there was a LEO, and now we have a CEO. That was interesting for me. It was very interesting. Talking about geosynchronous, and then middle, and then you go to Earth, low Earth orbit, and so on. So
Right.
it seemed like you're using some acronyms that will continue
Yes.
going.
Yes, yeah, we're very creative.
You are great. Now, you see, one thing is very important. Now, we look at climate manipulation. Do you think that one day will come that we can manipulate the climate through the satellites? I mean, is that possibility? As per experience, you see, you have seen all these from beginning till now. I've seen so many of these. Do you think we'll reach one day that we can really manipulate?
I think in the future, I think we will be able to get something, get there in some way, in some fashion. And that's, yes, it's a very good question in terms of how to do it, and especially being very careful that when we try to solve one problem, we don't create another one.
Exactly.
Yes. But I think that with technology, technology moves faster, and now it's exponential. Yeah, you know, at first it was growing slowly, but now it just goes up. Yeah.
Is there a plan in NASA?
No, I think that's good.
There is a plan for that. I mean, of this
I'm
kind
sorry?
of
What was-
is there a plan in NASA for data? Sorry, not data, but weather manipulation.
I
Well,
think
manipulation in the right way. I'm not in the wrong way. So yeah.
yeah, yes, yeah. I think there are talks about it, and it's a matter of identifying, what can be done and how to do it properly and carefully. Yeah. I don't know if in the UAE, I think that exists as well.
I think yes.
If I
Yes.
may add to this, I mean, some countries are already doing cloud seeding to push the clouds to drop some rain and such. But I read somewhat of a crazy idea recently. It was a theory. It was, I think, devised in the 1989. Well, back then it sounded crazy, but right now scientists are really considering doing that. I forgot the name of the particular scientist who came up with it, but basically what he said, well, you mentioned before that sunlight comes in, energy gets trapped, global warming increases. Well, the idea is, what if we can reflect it before it enters? So you put some sort of a glass body out in space, somewhere between Earth and the Sun, where there is equilibrium between the gravity of both, so that it would stay in position and reflect sunlight. And of course, if you want to do that, you would have to transfer a body of glass out in space, which is very difficult, very expensive, impractical. But since we've been to space multiple times now, people are thinking, what if we can build this body in space instead of carrying it as it is? And there are a lot of talks about this idea. Is it doable? Is it not? And what implications can it have? Because if you really succeed at it, Earth will cool down suddenly, and you don't know how that might negatively affect the planet. So I liked the sound of the idea, but
They say no idea is crazy. I say no crazy idea is crazy, because as long as their idea is not crazy anymore. And lots of crazy ideas have been implemented.
Right.
One of the things I like to also say it, we had, you remember Jetsons, the cartoon? He was lying down and he was doing exercise by using his brain to move his muscles. By just lying down. He finishes, he perspires, everything sweats, and then he has done his exercise.
That would be
so
good.
no crazy idea is crazy.
Yes,
It
yeah.
will happen.
Yes.
And I think this idea is, it can happen.
Yes, yeah. And the thing is that, what we thought was science fiction, years ago, are reality now.
Right.
There's a very old show, Dick Tracy. I don't know if I'm dating myself here. The watches, they can talk through the watch. And that was like, 30 years ago, 40 years ago. And now we have watches that you can talk to them, read your messages. Eventually, all that technology is going to continue, with on the eyes, the brain implants. I wouldn't be surprised to see that, at all. So the technology. And sometimes we think it's things of a science fiction movie or a book, but in reality, that they are becoming a reality. Yes.
You get ideas from them. You get ideas, actually.
Right. Yes. Exactly.
And I would like to build up on this point. You mentioned that the machines, if their processing power can be pushed more, if they can be faster. So we have Moore's law, right? Moore's law says that in the same space, the number of transistors you can fit on it doubles every year. But right now, I think we have pushed this theory to the limit, because it's reaching saturation. Because how many can you fit on such a small space? We have already entered the nanoscale, and now we're going into the quantum realm, where normal physics does not apply anymore. We have to deal with quantum physics. So now people are looking into quantum computers, and this idea is actually not new. It's been there, I think, since the 80s, but technology to implement it was not there. Actually, there is now a quantum computer in Google, but it's for research purposes. It has not been commercialized yet. But quantum computers now are what the current computers were to us in the 50s, where like, you know, one room has just one big computer filling it, and now we have computers on a chip. So this is the stage where quantum computers are. So who knows, maybe in, I don't know, 20, 30 years, we will be able to see quantum computers escalating all these processes, making them run faster, and maybe we'll even see quantum technology in space, maybe.
Yeah, Moore's law is always there because we find ways. That Intel invented a triple gate transistor for the same space, and 3 times faster, 3 times so on. So yeah, Moore's law still is okay. It's not stopping anymore because we have ideas to make it happen. Also, in United Arab Emirates, they're planning to have actually a colony in Mars in 2117. That's the plan from today. We'll not be there at that time, but I'm sure that our grandchildren or great-grandchildren will work on it to make it happen. So whatever vision we have, it will happen. If you don't have any comments, I'd like to give it to the audience to ask questions. Any question? Yes, please. Microphone.
Hello, hello. Yeah. So I want to ask the question from NASA, like. I want to ask the question from NASA, like you mentioned about climate satellites. So how does this data actually is accessible to the farmers, like in the small scale? The farmers are in this very small scale. They are in the very, lower stage. That how can these farmers actually use the data? Like the data are accessible to you, the data are accessible to the space agencies. But how these farmers, the public, can use the data to actually make it accessible for themselves? So this is my question.
Yes, and that is an excellent question. Yeah. And actually, that's one of the challenges that with all of this technology, and that hasn't been answered yet. How it can be made accessible? The farmers they are changing nowadays. For example, just 2 months ago, there was this a very large tractor that the farmers use to work on their crops, and it is completely automated, totally automated, and it's already for sale, available for sale, where the farmer he will have an iPad or some kind of computer, and from there he will give the instructions to the tractor, and the tractor will do its thing. Now that requires resources, of course, and some kind of technology in terms of not only the computers, but having the capability from Wi-Fi. So, and that could happen in some areas, but still that is a challenge. And that's why I say that's a really good question, because we have farmers that could have the capability for that, but we also have farmers that, it's a family-owned farm. They don't have the resources. They may not have the resources to have technology like that. So it's a problem that we need to work. And when we have a lot of students, when we have problems and we have a lot of students, and I always think that the students here, they're gonna help us come up with the solutions for many of the problems. Yeah. Sometimes I think you are gonna solve the problems that we're creating today. But so what we need you is to start thinking about how to address those problems. And we work today, our agencies are working today to do as much as we can, but we also still need those new ideas, thinking outside the box, out of the box, to come up with those answers, like this question and other problems, how we can, for example, how we can get to that one farmer in the middle of the country, very isolated, with no Wi-Fi, no computers. How could we make this information accessible to people in these kind of locations? Yeah.
Yeah,
Do
I
you
have
have-
one more question.
Do you have a platform for it that can get ideas? Is that a NASA? Do you have any platform for it?
We do have ways that you can access comments. As a matter of fact, and I'm going to talk about that in another session tomorrow morning.
Okay, then
Yeah.
don't say much.
But there are ways that people can interact and bring in solutions to some problems. Yes, so we have
that
access to that as well.
Yes, another question. برجع لك خلي حد ثاني. He was here somewhere. Here. These lights are
Yeah.
too much.
Hello, I'm Sandy from Cairo, Egypt. By the way, I'm Miss Egypt 2020. And I actually have two questions. One is about Mars colonization and one about the Earth. So which one shall I start with?
Whatever you like.
Okay, I'll start with the one about the Earth. So we know that according to some reports, we've known that during the pandemic, because of the lockdown, the ecology has become better and has improved. So if this can help, why don't we digitalize our world more and have like some sort of lockdowns to let the Earth rehabilitate? Or maybe maybe the COVID-19 plan was already a plan to save the ecology. So please, I want the answer.
And the second one?
Excuse me?
The second one?
Okay, the second one is about Mars colonization. Excuse me. I read according to Aram Berliner from the University of California, Berkeley, and Chris McKay from the Space Science Division at NASA Research Center that it would take about 100 to 100,000 years to terraform Mars. So why don't we make such a bubble and invest this time in like living in some sort of limited place until we terraform the Mars? Yeah, thank you. These are my two questions.
So thank you. The first question?
Mhm.
The first question? What? Can you remind us the first question? Sorry?
The first question was why don't if quarantine helps the Earth
okay.
and
We
the
got
ecology?
it.
Yeah,
Yes.
why-
I think this is a very actually excellent idea if you look at it carefully. What she's trying to say, why don't we have that kind of lockdowns to just to save the earth in a way?
I think it's economical reasons.
Uh-huh.
Of course, people would love to do that, but some businesses during lockdown suffered and could no longer continue being in lockdown. You have to compromise something, and unless people are willing to compromise economy, we won't be able to do
You can
this
do it
for a long
once a
time.
month, one day a month. Right?
I mean,
Yeah,
why don't we help our Earth?
Of
Yeah.
course,
If we've done this for COVID-19,
Right.
why can't we do it for other
Yeah.
reasons?
But this I can answer also. You see, economy plays a very important role for the betterment of humanity. We have to balance it actually. We have to. It's just not say, let's save the earth and forget about economy. Then you not save the earth anyway. So there should be some kind of compromise between the two. That's why you said maybe one day per month could help also. But do you have any?
Exactly, we can make it up.
Yeah, from a COVID perspective and at NASA, at the NASA centers, we are still working from home. Yes, still to this day, except if you're working in the mission control area that you have to be there, of course, in person. And NASA is right now studying different options in terms of coming back to work. And there's the possibility of a hybrid condition where people would come to the office 2 or 3 times a day, and then a week, and then the other days they will stay and work from home. Now, from that perspective, I think within NASA, and I don't know, some industries may benefit more than others from working remotely. I think at NASA, we can work remotely because we use a lot of technology, but what we've noticed is that we've missed some of that connections that happen in a more natural way, natural environment.
Right.
We've missed some of that, and that's why we want to go back so that we can continue with the goal, so that we can get to Mars eventually.
Yeah, sure.
Yes. and we can get to that other question.
The other question was about terraforming Mars?
Yeah, why don't we invest those 100 years, or why don't we start in building or colonization from now on? Why don't we make a limited bubble for some people, for some industries, until the terraforming process goes on?
Well, I can start with. Do
Sure.
you want to?
No, that's
No.
fine.
No, from that perspective, and it's a question that we get a lot. Why are we spending millions or billions of dollars going to space? Why don't we spend it here? So it's a question that we get a lot. But one thing that what we want to do is to continue with our species, the human race. We want to make sure that we have human race continuing. For example, NASA has a mission to explore the possibility of pushing a meteorite, an asteroid, in the event that it would come and hit the
I
Earth,
heard about
and then
it.
we could go into another disaster, like the dinosaurs, the extinction of the dinosaurs. So, and that would wipe out the human race from the Earth. So that's one aspect that we want to make sure that we want to have the human race in other places, not just in this one and only planet that is here today, but may not be here 500,000 years from now. So and we usually think in terms of our lifetimes. Why don't we do things for now? Why don't we do things for the next 20 years, for the next 50 years that I will see during my lifetime? But we need to think of our generations, and the next generation, and the one after that, and the one after that, because they are the future, and the future of, again, the human race. And I'm thinking of the possibility of an asteroid hitting the Earth, which has happened before. So it is not something that would never happen. We cannot say for sure that will never happen again. But also in terms of, we want to protect our planet, and we want to make sure that it is habitable for the human race. So, and if we don't do that for whatever reason, we don't take care of our planet, then we need to make sure that the human race still exists and continues on somewhere else.
Well, actually, that wasn't exactly my question. I meant, why don't we make the bubble on Mars? Why don't we construct an habitable, limited area on Mars and parallel work on terraforming it?
Oh, I didn't understand the question. Sorry about that.
No, it's okay. I think that's possible, but it's not easy to do today. There was a project actually to have a colony in UAE, one space we have somewhere, to actually build a Mars colony in UAE with complete environment of the Mars. That means we do everything required for human being to live will be in that colony. You need energy, electricity, you need food, you need water, you need cooling, you need oxygen. All these together should be self-sufficient.
Yeah.
So there were experiments done to actually look at it at this colony and see, will it be self-sufficient if we take it to Mars, or if we have it built at Mars? They take time. And to build there is not something easy.
Yeah, I
For
know.
somebody being there for 7 months in a probe, it's not easy. All these together, difficult. So time, when you say time, yeah, it takes time. But they will build something in Mars, future. And when you look at Star Trek, they're talking about thousands of years from now sometimes,
Yeah.
right? So you can't do it today, you can't do it tomorrow, you can't do it 50 years. But that's the plan is 100 years from now. Maybe you can do something there. But from now we started.
Yeah.
If I may add, yes, this is a big step, and you really need a lot of baby steps before that. So people started with studying the soil and rocks on the surface of Mars. Until we understand these, we cannot build anything there. So that's the first step the scientists are at, actually. It's still a bit early to talk about building something there until we understand that first.
Well, when you plan to build something there, please take me to your team.
Sure.
Thank you, everyone.
There's one question. There's somewhere else.
Hi, my name is Abdurrahman Hatem. I'm a software engineering student at the Egyptian Chinese University. As a software engineering student and as a founder of a startup, a young startup, do you think we will ever see a collaboration between Mohammed bin Rashid Space Center, NASA, and other young startups to develop different types of solutions for the problems, the minor problems, while you guys work on the major problems?
Well, actually, there is already, it was launched 2 years ago, I think. There were 9 Arab countries, 9 of them, right? 9 Arab countries to collaborate on the future space shuttle. So there is a space program, sorry. The collaboration started.
Okay, can you tell us more details about it and how can we join?
Right now, there are no details yet. They signed an agreement, but we don't know where they are now.
So it's still in the works.
Yes. It's
Well, I hope one day when it's done, I
It'll
can
come
be
soon.
part of it.
And
It'll come soon.
I think you should keep an eye about some competitions MBRSC announces from time to time. Like recently, they announced a competition for autonomous detection of palm trees. They were encouraging young startups to present their solutions, and of course, whoever wins, MBRSC would provide them with full support. And we had like not just one winner, but 1, 2, 3. So perhaps you should keep an eye on that. It's a good opportunity for young startups.
And there is one space apps competition in the Arab world, but started from Egypt actually.
Yeah, we do work.
Yeah,
with
and we are
the
actually
NASA
doing
for-
it here in Dubai, with University of Dubai, working on that also. It's a collaboration of space apps. Also, we have the NASA apps done by World Green Economy Organization. Headquarters is in Dubai. That's another one that we're working on. I think we had finalists, and one of them will be participating in United States or the NASA apps competition. So yes, there are lots of collaborations, but the Arab world, it started already. They signed it 2 years ago, I think. Exactly, I can't tell you. And we hope that, you see, UAE, one thing we do, whatever we do, we want to disseminate it to the Arab world. We started from here, and slowly we grow with the Arab countries. So inshallah, we'll work together.
Inshallah. Thank you so much. If you would allow me to add, we're currently working on a project in my startup that utilizes augmented reality. Because we believe augmented reality could be a solution for astronauts and their missions, especially for fitment testing.
You're talking about augmented reality?
Yeah.
Okay.
The usage of augmented reality to test the spacesuits on astronauts and training astronauts before they get to space, and we can simulate the entire room and the entire environment for them. But we still don't know how can we communicate with either of you guys in order to showcase it and maybe do some sort of a small live demo or something.
The best thing to do is to go with the apps, I think, the competition of space apps. The one who's in charge of, Hamid Aboud was here yesterday, I don't know, today is not here. He is the one who actually running it completely. He's from Egypt, and we work together a lot.
All
So yes, you can. The one we won from Dubai, we are going to NASA apps. It's called the Locust project. Actually, in northern part of Africa, there's a problem with locust, Jarad.
Yeah.
And so there was a very innovative idea how to monitor exactly what's happening, how to expect. If you started from here, you know that tomorrow will be here and so on. All this that's the one that's won to be a part of the main big competition around the world.
All right. Sounds awesome. Thank you so much.
Please, you come. There's a second question? Yes, or third question.
So this is a question related to collaboration with the countries like... Okay, this is the question related to the collaboration, not with us, but many countries in the world, as Sir mentioned about, the countries which are not able to contribute to the, the climate change improvement. So there are many possibilities to it, like sometimes they don't have a space agency, sometimes they don't have proper budget to it. Like I won't give an example right now, but they don't have a proper budget to it, they won't have proper system to it. So, like, what does NASA and what does, you know, the organization of UAE is probably planning to do, you know, towards these countries? Like, as already sir have mentioned, that, you know, these countries are not able to contribute. Like, they don't have a budget, okay? They don't have specifically, they are not able to afford a satellite. They are not able to afford even a rented satellite. They don't have a space agency. And they are not able to even provide a satellite to their own country to provide a navigation. Then how can they able to provide the a climate change possible solution to their own country? So this is how these countries are not able to, you know, go forward with the collaboration towards the climate change. So we want to know that how NASA and the UAE Space Agency would like to collaborate with these countries and make the things happen.
A country in your mind, is it a specific country in your mind or general?
No, I don't have any specific country in my mind, but I just came up with this thing like, you know, countries let's say in Africa, okay? Or let's say in South Asia. So there are many other countries. Like I'm from India, we have a space agency, but many other countries in the South Asia don't have a space agency.
There's
You
no
wanna go
clear,
first?
there's no clear answer for it, but at the end, they will work. It's not that, you see, these projects cost a lot of money. The budget is high. So in order to first let them succeed, then they can slowly go and propagate and go to other places. So I don't think you can go to those places if there's no budget for it that can do it. It's very expensive. But I don't know if you have any other answer for it.
I think for some issues, not necessarily each country has to have its own separate satellite. I mean, after all, the environment crisis is not just on Earth. We're starting to have a lot of debris in space because of the
The waste.
satellites that expire and then they're left there.
Space
for
waste.
Yes, space waste. So I think not for every issue you have to have a satellite for each separate country. As I mentioned before, for risk assessment, we worked on issues related to tsunami, and it hit some countries in South Asia. These countries don't have satellites, and yet we were able to do the risk assessment, change detection, and present them with a plan to prevent this from happening. So all that really has to happen is collaboration between the governments and not necessarily collaboration between the space agencies. That's at least how I see it.
Thank you. Thank you very much.
Yeah.
Thank you so much.
And in fact, I wanted to add to this, on the website climate.nasa.gov and science.nasa.gov, the information collected by the satellites is available for everybody. Yeah. So again, you don't have to have a space agency to use that data. It's accessible to all. And I can easily see a university in any country using that data that is available to them and specifically look at it from the perspective of their country and how they can contribute in a way. So that analysis by itself, yeah, like you mentioned, that not every country needs a satellite, but actually there's a lot of data already available that you can use, or any country can use through universities. Some of the, actually, as a matter of fact, and some high schools, intermediate schools can actually even will have access to that data, and they can start that analysis from there. Eventually, it will grow and continue growing into universities, continuing with the analysis, and private companies. But again, you don't have to have a space agency to have access to the data and then make a difference in your country.
Actually, I had a little bit doubt in this. Like, I had a similar question to this. Like, I had a question related to collaboration. Like, how does NASA collaborate with these countries, like NASA and UAE Space Agency, collaborate with these countries, like, you know, which does not have a space agency and which are not able to afford it? So, is there any kind of a plan or a future plan, maybe not right now, okay? Or maybe some kind of, you know, things that they might provide to this country, not on the website side, but on the governmental side, so that they are able to do it.
Yeah, there's on the NASA side at least, there's a website, nasa.stem.gov, and through there, there's a lot of information, and through there are some specific applications that you go and you can help NASA with specific activities, searching for exoplanets, for example. I mean, that's one where you can have access to data, and you can access more information and more ways, actually, to help and collaborate with an agency.
Okay, thank you so much.
No other question? There is one.
I have one here, one there.
There's a hand raised there.
Hello, my name is Sulaiman Muhammad from Kuwait. I have a question about space. Do satellites collide with each other in space?
Ideally, they don't.
They don't?
They're not supposed to.
They shouldn't.
Because there are a lot of satellites in space, so they don't collide with each other?
Mhm. Sometimes, technically, if it's an operational satellite, it should not. It's been kept track from the ground, and so it shouldn't happen. But there's a lot of space debris, a lot of the space trash.
Yeah.
And that is very dangerous. I mean, from a space station perspective, not only from the satellites, other satellites, but from a space station perspective, the space station actually has to make movements to avoid debris. I mean,
It's mainly the debris, not the satellites.
Mhm.
They don't collide, right? It's not happened till now. Collision.
I don't think operational satellites that have collided. No, not if they're functional. Yeah. No.
I've never heard of a case like that.
No.
Has
But
it happened?
you know, some fake videos they send, I think that's what it is. They show some fake videos and
But
and
it's
there's
a
a collision, but it's
good
not there.
question, worth thinking about.
Well,
Yes.
yes.
Yeah.
Why is that question?
I was thinking about it.
No, I know, but I mean, is it something that we need to think about, or
Have you
maybe,
seen or read any article or?
No, I didn't.
maybe we're trying to say the next time make sure that whatever is happening, you see, they go around either Geo or Leo or Mio at the end. They go according to certain speed and so on, and the number is already calculated not to exceed a certain number of satellites per orbit, right? So, but it's a good question. I think it's
I think,
good to know.
yeah, because like the space is vast, what are the chances that two satellites are orbiting on the exact same height? I think it's a very low chance.
Okay,
Yeah.
thank you so much.
Yes.
Another one? شوف فتحت المجال الحين. What are the gases used?
ما هو نوع الغازات الناتجة عن إقلاع الصاروخ
آه.
ومدى تأثيرها على الطبيعة؟
The gases that are that come out from the rockets, how bad are they for the environment?
Well, yeah, there's combustion there, so they're not good. They also impact the environment. But I believe there's a study on what is the actual impact and how to mitigate or reduce that impact. But yeah, that's a very good point, that we need to learn how to burn fuel more efficiently, cleaner, so that we ourselves don't contribute to the problem.
Yes. Thank you, sir.
Yeah, I think you're saying that you have to look for other kind of energy resources than
Yes.
just combustion and so on. If you don't have any question now, thank you. We still have time. Yes, yes. That lady. And there's one here also. The last two maybe.
Like you mentioned, this climate change, it's a global problem and we all need to work together to solve it. Do you think maybe collaborating with the United Nations to have a agency in every country for this specific activity would help?
So what you're saying is basically have the United Nations allocate a budget for each separate country so that they would have the means to collaborate with us?
Yes.
Or any agency, okay. Yeah, that's a very good question, but I guess like you have to take it with the United Nations, you know?
No, but do you think like it would help if like there was an agency in every
course,
country
yes.
for even with like a limited budget, but because you know every small action has can have a big
Right.
effect. So having an agency in every country to have every country helping with this, even if there's like a very limited budget, like would it have like that big effect we're looking for?
Right. I think they don't really have to have a space agency. There are universities, and the universities have researchers and really bright minds. And it's not unusual for a space agency to collaborate with a university research lab. MBRSC has done it once with a research lab in University of Toronto. So it doesn't have to be necessarily a space agency. It can be done through the government, through universities, through a research group or lab. I think it's a very flexible process.
But she's talking about climate change only. Climate change. Can you have United Nations that's not the satellite?
Yeah, I think that would ease the process, but it's not the only way. If a nation reaches out, I'm sure the space agencies will not say no, you know?
And they have the SDG, you know, the SDG, that they have 17 goals, and these 17 goals are actually propagated around the world. But who is being funded, that I don't know. But I think it's always the country asks for a fund, submits a request, and they fund it. But it's not like we have a specific agency anywhere. And United Nations, they have every country, they have a representative, I think.
Yes, yeah. And sometimes, yeah, there are ways, and going back to how you here will be the problem solvers, you know, we'll be solving our problems in the future. Not only you will be you're the scientist of the future, but you're also going to be the politicians of the future and making the laws. And so it's going to be you. And again, you know, 10 years from now, 20, 30 years from where we are today, it's going to be you sitting at those tables making the decisions and collaborating, whether if it's a space agency for each country or collaborating with universities. You know, there's a lot of talent there. So there are different alternatives, and sometimes if you don't see change, then you have to be the change. You have to implement the change, whether if it's today or 10 years from today or 20 years from today, that you're getting ready, and everything that you're doing today is leading you up to being the change. So I think it's very good point.
Thank you. That's all.
There is one big project, it's called His Highness Mohammed Rashid. It's called Global Initiatives. Mohammed Rashid Global Initiatives, and many goals. The goals are as following: the poor societies, they will build schools in these poor societies around the world. It's not chosen specifically. They are going to build schools. Till now, they've built more than 2,000 schools. They are going to build hospitals, so they eradicate diseases, get rid of illiteracy. Plus, they are going to also train the teachers, provide books for these poor societies. And the last but not the least, there is a project that to make them self-sufficient economically. So they are going to try to what do you call it, fund entrepreneurs who have ideas to create companies so that they could be self-sufficient economically. That's a very big project in Dubai. It's been going since 2016, I think. and it's very successful. This is one of the reasons why we say that UAE, we are global. We are not just working for ourselves, but also for others. If every country does that, as you know, the famous Chinese saying that don't give the person fish, but teach him how to fish, right? So that's what we are doing. If all of the countries, rich countries, do that, I think everything will be fine. And this is a very good initiative and one of the best actually in the world.
Thank you.
So they had, it was the last one, right? There was one here. You still have that question? Is that? So now I'd like to thank you all, and specifically thank George and Noor for this.
Thank you.
The mic is off.
No, it's okay. Yeah, I was thanking you too, and I think it's a very interesting subject, especially getting more questions from the audience. This is the best thing I think it is, because you have a lot of questions to ask and some ambiguities, and they are here to help us understand the space. And I think satellite has played a very, very, very important role in the development of this world. Since it started, communication became easier, internet became easier, 5G became easier. Any new technology around the world are actually the source of it to get the information coming from satellites. So satellites are here to stay, and satellites are here to help the country, help the Earth to become a safe place to live in. Thank you very much, and thank you all for listening.
Thank you.
Thank you. Thanks.
Let me give. For this contribution, please come.